Okay guys, now we're going to do the first part of the data collection, which is the bottom of page 18. So we are looking at doing refraction through our setup. Okay, we have our vegetable oil here. I have the plate along the line. I have the center of the plate in the dot. So this is going to be vegetable oil. And I'm going to shine this laser light so you can kind of see it. That's why I hate this camera. And I'm going to shine it along that line. And then I have to figure out, I got to hold it steady. And then I got to make sure I mark where it goes. So that's right here. And that's why I said I got to hold it steady because I got to get it just right through the light. Make sure it's on the material. And then I got another spot here. So I have my two references so I can now measure. So I'm going to take my protractor. I'm going to extend the line. And now I have to measure this angle, this one. Okay, that one right there. So I'm going to take my vegetable oil off. And see, I'm measuring this angle, that one to there. So as I measure that, that means that when I go to put this down, I put it like this, and I line everything up. So it's right here, which is going this way, 47.0 degrees. So 47.0 degrees. The angle of incidence never changes. It's 30. Okay, so for vegetable oil, because I can't show you the table, it is 47.0 degrees as your angle of refraction. Okay, 47.0 degrees. So you might say, why do I have the yellow book up there? It's so I can see where the laser goes. Sometimes it makes it easier. So for vegetable oil, the angle of refraction is 47.0. So let's go on to the next one. Let's do water. Move this over. Here's water. You put it in the proper place. Line it all up. And again, I'm going to put my laser light down. Move this way to get the heat. Oh, come on, don't lose batteries on me now. Figures. Okay. Okay, fix that. Here we go. Now we have a nice bright laser. Make sure I got it on the line, going through the water. Here's a spot. There's the spot. There's the spot. Now I'm going to line that up with my protractor, like I did before. I like this is boring, Miss Sylvester, but this is part of the experimentation. I know you guys don't get to do it, so it's not as thrilling. I understand that. So now, oh, I didn't do a good job on that. Slipped right on the end. Let me make sure I'm doing a better job. There. Give it into the center. Yeah, that's a little bit better. And now I'm going to measure my angle. Again, matching up everything, making sure everything's on the lines and parallel to the crosshairs. And this is 40.05. No, sorry, 40.5. Right? 41, yeah, 40.5. So for water, it is 40.5 degrees. That's what I get. For water, it is 40.5 degrees. Okay, the last one is our very odoriferous clove oil. Some people hate the smell, and some people who are in class are like, I really can't handle the smell of the clove oil, it's too strong. It actually eats away at this plastic. A lot of chemicals in the clove oil keeps away bugs. So now we're going to do the clove oil. Make sure you get it on the line here. There's our 3. I know you probably can't really see it that well, guys, but just bear with me. Take that protractor, line it up, do the center best you can. Line up my little circle. And it is 48.5. Whoops. All right, so clove oil is 48.5. I hate this camera. 48.5 for clove. I know, you're like, I can't read that. 48.5. All right, now we have to do what's called the back lines. Okay, the back lines. Where am I? No. Oh, there it is. Okay, that's this page. Right? Where you're ranking it. Is it like it? Does it disappear? That's page 19. So backline data. I'm going to quickly write this down. This is 48.5. This is 40.5. The reason why I'm writing it down, guys, is that I'm going to look at it when you guys go and put your data in and upload it. I'm going to make sure that you copied down the right data. So we're going to take clove oil and I'm going to put it in this container. And then I'm going to dip things in it. Now you might not be able to see it very well, so you're going to have to rely on me saying, oh, it gets bigger, it gets smaller, a lot, a little. I just won't do this freehand over the lab bench because, like I said, clove oil smells. If it spills, it smells a lot. Like my room's going to stink of clove oil because I have no ventilation zone at all. So we're going to go through, and I'm just going to go down clove oil, and I'm going to look at Pyrex glass, lead crystal. I'm going to grab a piece that's big enough for me to use, and then I'm going to put it in there. And then I throw these pieces out. And I'm going to make sure that it'll fit. Yep, that'll fit. So here's Pyrex. What we're going to look at, and I'm going to take my little light so I can see. And I'm looking to see if I can get this so you guys can even see it, whether or not the glass disappears. So if I put it in there, I'm like, oh no, that does not disappear. Like, I can see the Pyrex. I don't know if you guys can see it, because I can't even see hold on. This is what I hate about how we have everything set up. I can't even see what you see, what's being filmed. Sucks. and this is, administration has no clue what goes on to teach. They're so far removed. In science, oh God, I don't think any of them have any idea what the topic science is. Okay, don't. So I put this in, and I'm trying to see underneath. Does it disappear? Does it get bigger? Does it get smaller? Okay, so I'm gonna move the light. I don't know if this is gonna work, guys. I know you can see it a little bit. I'm gonna try to get more light on it. You can see more light coming through now. And then you go, does it disappear? Now, to me, that does not disappear. And to me, it gets bigger, and it gets sizably bigger. I'm going to say Pyrex gets bigger by at least 3. I'm going to actually go and say 5, because that's huge underneath there. Okay, so when you go to record your data over here, I'm going to say for Pyrex, it's bigger, and it's at least, I'm going with the 5. That thing was huge. Now, I might have to adjust that because it's all relative, and I'm going to say it's way off, which means Pyrex is going to be smaller in refractive index than clove oil. Okay, so that was Pyrex. I'm going to put it in the garbage part. Let's go, what's the next one? Lead crystal. So here's my piece of lead crystal. Do the same thing. Take it. I'm going to put it in. Ooh, that's pretty close. That almost disappears. Ooh. I'm going to say it gets bigger by a factor of 1 because it almost completely disappears. At least with the way the light's hitting it. It doesn't quite disappear, almost though. It's close to a 0. And then we have tempered. Oh, tempered's hard because I don't have very many pieces that are big enough to do this. Because tempered shatters into a ton of pieces. So here's one. So here's tempered. And I put it in. Oh, that's like Pyrex. And not quite as bad. I'm going to say it's about bigger by a 3. Now flat glass, and where's my flat glass for this? Flat glass and tempered are very similar. Tempered just goes through heat and cooling. So I'm going to hold this up and put it in. And it does get bigger. Not very much, maybe a 2 to 3. I don't know if you can even see that. So I'm going to say bigger by a 2 to 3. Okay, so none of these have a refractive index higher than clove oil. So I'm just going to cap this up for now so I don't gag on it. Oh, I don't really mind the smell of clove oil. Okay, let me get another one of those little guys. Over here. Right there. We're going to do vegetable oil next. That's a little bit too much. So here's my veggie oil. Pyrex. Trying to get a straight piece. Alright. Oh. My hand's kind of in the way. So let's see. Dropping it in. I can see the writing, but the edges disappear. Ooh, hold on a second. Let me see if I can get one without any writing on it. Because what you're seeing is the writing, but the edges like completely went away. Yeah, this one doesn't have any writing on it. So let's see what happens. Now we might see the crack. But if I put it in, Yeah, I can see the crack, but the edges completely disappear except for the very bottom. So that's really like equal to it. If you look at the left and right side of the glass, there's no distortion. You can't really tell where the lines go down into the oil. So that's a 0. So Pyrex has a 0 in vegetable oil. There's no difference. All right, let me get another piece of lead crystal to dip in here. Again, I have to do something different. I can't use the same one because it cross-contaminates. So I'm trying to hold it so you can see the oil in the light from behind. And then I put it in. Ooh, that looks bigger. Not that bigger, but I can see that the crack looks larger. So I'm going to say bigger by about 2. Which is not what I expected. All right, and then we have tempered. Let's see if I can get another piece of tempered here. Tempered is tough because it breaks into such tiny pieces, and you gotta try to get one that you can hold onto and dip in and see what's going on. Here, let's see if this one will work. Here's tempered. Ooh, it's definitely bigger. The edges move away, so I'm gonna put bigger by 1. Yeah, 1 to 2. Right now, we figured out Pyrex is the same one as, what's it called? Vegetable oil. It's the only one we really figured out. Window glass. That's also bigger. It's wider. It shifts. The edges shift. So I'm going to say it looks like it's bigger by about a 1. It's not as big of a change as in clove oil. So it's probably got a refractive index closer to vegetable oil than the clove oil. Okay, now we gotta do water. Oh, that's a bummer. That's messed up. That should have gone in there. Okay. Just gotta get some more water, guys, because my piece of glass that had oil in it fell into the water. So where I placed it. Here's the water. And we start out with Pyrex. Let's see if it'll fit into that. Trying to find one again that doesn't have a lot of numbers on it. Pyrex. And there is a shift. This is way bigger. This is like bigger by 3, which is weird. It should be smaller. And then lead. What happens with lead? Shifts. Sharper. It's hard for me to tell because it's so, like the edges are so distorted on the lead. It doesn't disappear, but it's almost similar. So I'm gonna say that it gets sharper, the edges get sharper instead of more distorted by 1. So it means it's probably closer to water than anything else. And then we get tempered and flat. And just looking for a big enough piece of temper to put in there. Here's the temper. Temper gets bigger by 3. And the flat. Bigger by 2. Trying to look for like sometimes they say you get a glow around the edges, and that'll tell you like the edges get more defined. And it's really hard to see with this light. Now what I'm going to tell you on the bottom, you're going to make your best guess, right? Because you're looking at which way these went. Only one that we can really definitively tell is Pyrex. But this one was, sharper at the low end, and it looks like it's closer to water. And these look like they're closer to vegetable oil. And they went the same way. So use your best judgment. It's going to fall between these somewhere. So you're just estimating. Okay, that's to fill out this part here. You're going to fill out the bottom part right there. Okay, that's the end of the data. Okay, your part 4 for the lab, which is not going to have any, data to do because you finished all the data. Your part 4, and I'll give you instructions separately, will be to answer the questions on page 27 to 28. That will be the part 4. So if you are someone who gets this done quickly, you're done and you have more time, you have nothing